Welcome back to the Deep Dive. If you've been following the world of AI over the last couple of years, you know the term chatbot has really dominated the conversation.
Oh, absolutely. It's been the digital assistant, waiting patiently in the chat window, ready to summarize something or
Yeah.
whip up a draft email for you.
Exactly. Based on your last command.
And it was wonderfully powerful, but it was fundamentally passive technology. You had to initiate every single action.
Right.
And it didn't have persistent memory or the ability to truly act in the world,
hmm
outside of just generating text.
But the stack of sources we pulled for today,
Mm-hmm.
well, it shows we have decisively left the era of the passive chatbot.
We really have.
We're now confronting and leveraging the age of the specialized, the autonomous, and, crucially, the goal-oriented system.
Mm-hmm.
We're talking about the complete operational shift enabled by this thing called the ChatGPT agent framework.
And that is absolutely our mission today. We've gathered the architectural blueprints, the operational documents, all the stuff detailing this transition.
So we're going to unpack how this framework works internally.
Exactly. We're focusing on the architecture that allows a non-coder, someone who just relies on natural language commands, to build really powerful AI automation.
Automation that can handle complex, multi-step, professional-grade tasks.
That's the goal.
Okay, so let's get the core definition down right away. When we say agent framework, what are we actually talking about? How has the engine changed?
At its core, the ChatGPT agent framework is a built-in integrated system. It's designed specifically to let you create specialized AI agents that are goal-oriented, tool-powered, and persistent.
Okay, goal-oriented, tool-powered, persistent.
And the truly revolutionary part here, and we really have to emphasize this up front, is that you do all of this with absolutely no traditional coding required.
That accessibility point,
Yeah.
it's massive. It means the barrier to creating this kind of high-functioning automation has, well, it's dropped to basically zero for anyone who can write a detailed paragraph.
Precisely. You should really stop thinking of the interface as just a chat window. Think of it instead as a complete integrated development and deployment environment for these AI agents. It brings together all these critical elements that were, previously separate.
Like what?
Well, you've got natural language reasoning, the ability to execute external functions with specialized tools, integrated long-term memory, automated scheduling,
Wow.
dedicated document workspaces, and even multimodal understanding. And it's all operating coherently, under one standardized architectural roof.
So the key takeaway here, before we really dive in, is that the large language model, the LLM, it's not just the conversational part anymore.
No.
It is the full development environment. It's the platform.
It's the platform on which you can build sophisticated, reliable business logic.
Okay, let's transition from that foundational definition to capability.
Yeah.
If we're moving from a passive chatbot to an autonomous agent, a system that can actually, self-direct and execute complex tasks for you, what are the non-negotiable architectural principles? What gives the agent its capabilities?
Well, to make that functional leap, the system has to adhere to 5 core pillars of design. These are the elements that make sure the agent moves from just giving you advice to actually taking action.
Let's start with the big one, the behavioral change that defines this whole shift. Autonomy?
Autonomy is definitely the first and most defining pillar. It means the agent can initiate decisions, it can dynamically decide which tools it needs, and it can complete a task or even a complex series of tasks without needing the user to intervene or confirm every single tiny step.
That's the major difference. The user says, draft the preliminary report on the Q3 market data, generate 5 charts, and schedule a reminder for me to review it next Friday.
Right.
The older system would just stop after the first paragraph. This new system plans the whole thing, executes it, and then schedules the follow-up without you lifting another finger.
Exactly. It operates on this assumption of self-direction toward the final goal. But this raises a really important question, one that you out there might be asking. Autonomy sounds expensive. If the agent is just allowed to keep executing steps until the goal is met, isn't there a huge risk of it just spiraling off on some expensive, unproductive rabbit hole?
That's a crucial architectural challenge. Yeah, if the agent gets a bit too enthusiastic, costs could just skyrocket.
Well, the control mechanism is actually baked into another principle we'll discuss, the reasoning engine. But fundamentally, autonomy is constrained. It's constrained by the system prompt and by the available tools.
Okay.
So the agent is constantly comparing its current action against the defined goal and the toolkit it has. If it figures out a step is leading to, say, diminishing returns or needs a tool it doesn't have,
It pauses.
the reasoning engine is designed to pause, summarize the problem, and ask the user for clarification. So the agent is autonomous, but only within defined boundaries. It's not limitless.
That leads us right into the second pillar, which is tool use. Autonomy doesn't mean anything if the agent is still trapped inside a text window.
Right. To be functional in the real world, the agent has to access specialized, specific functions. Tools are the agent's hands and feet. They transform the LLM from a purely communicative thing into an active agent of action.
And we're talking about things like browsing the internet, running code.
Browsing, executing structured data manipulation with code, running specialized searches on your documents, managing calendars, schedules. The quality and the sheer breadth of this toolkit really define how effective the agent can be.
Okay, so once the agent starts executing these complex, multi-step tasks,
Mhm.
you need continuity. I mean, nobody wants to redefine their entire project scope every single hour.
And that brings us to the third pillar, memory. Agents are designed to store user preferences, specific stylistic requirements like, a corporate tone or a certain writing cadence and long-term goals.
So the memory ensures continuity not just in one session.
But across different projects and even multiple different agents that you build, if you've defined a really sophisticated style guide, the agent refers to that memory, which saves you the trouble of prompting those details over and over again.
So memory stores what you like and who you are. But for massive projects, the agent needs a specialized place to structure that long-term output.
That takes us to the fourth pillar. The sources call it the long document workspace, or sometimes the Canmore tool.
And this sounds important.
This is a truly pivotal feature for any professional user dealing with complexity. Canmore is not just some folder. It's a dedicated, structured environment that's optimized for the agent to create, store, edit, and maintain really complex, very long documents.
So we're talking about projects that exceed typical memory limits.
Exactly. Think about drafting a full 500-page book, or managing a complex regulatory filing with hundreds of cross-references, or writing extensive, structured educational material.
But why couldn't we just do this with the older LLMs? Why do we need a dedicated workspace for these huge text projects?
Previous LLMs struggled massively with two issues when the context windows got really big. First, maintaining structural integrity.
Right.
If you asked an LLM to revise Chapter 7, it often had a really hard time understanding how that related to Chapter 1. You'd get inconsistencies, what's called context drift.
And the second issue.
The second, and this is the most critical one for professional environments, is that previous systems could not reliably manage version control.
And version control is absolutely non-negotiable in fields like law, finance, or collaborative technical writing. You have to know what changed and when.
Exactly. Canmore solves this by creating an internal structured file system. The agent understands that Chapter 4 is distinct from Chapter 5. If it makes a major revision to a section of, say, a legal contract, the agent can track that change historically.
So you could have a 300-page compliance document, and the agent needs to track 15 different stakeholder revisions.
And verify that specific clauses remain intact. Canmore is the environment that makes that traditionally manual, error-prone, super time-consuming task possible for an AI agent. It transforms the agent into a collaborative, structured co-editor.
That really does shift the paradigm from just generating content to full-on project management.
And finally, the fifth principle is consistency. For an agent's output to be usable in an automated chain, for example, if Agent A's output becomes Agent B's input, that data has to be reliable.
It has to be predictable.
Yes. The framework enforces the generation of highly structured outputs. Perfectly formatted JSON objects, clearly labeled tables, standardized bullet points. This strict reliance on structure ensures reliability, which is just paramount in any professional workflow.
Okay, so that gives us the high-level view of what the agent must be capable of. Now, let's get under the hood, because this is where the real sophistication is.
Right.
We need to unpack how the system takes a simple natural language request and turns it into a structured, reliable, autonomous workflow, all without the user ever seeing a line of code.
Well, the whole process starts with defining the agent's entire universe, its DNA, which is the system prompt.
The agent's identity.
Precisely. The system prompt is the core foundational set of instructions that determines, well, everything. The agent's persona, its required tone academic, sales-focused, strictly impartial, the specific rules it must always follow, its operational scope, and its hard limitations.
Let's use a real-world scenario. If I'm building a, say, financial regulatory agent, the system prompt might be thousands of tokens long, right?
It could be.
Defining things like, you are a specialized compliance auditor, you focus only on U.S. GAAP standards. Your tone must be rigorously formal, citing all regulation numbers. And your limitation is you must never advise on specific implement strategies.
That's a perfect example. That foundational prompt dictates all subsequent behavior and constrains that autonomy we just talked about. But what happens, and this is critical, when that foundational prompt conflicts with a developer setting or a user request or even data it pulls from a tool, that conflict resolution is managed by the instruction hierarchy, or as some sources call it, the behavior rules.
Okay, let's unpack that hierarchy because it really defines the operational integrity of the whole system. It's a priority stack for resolving contradictory information. What's at the top?
At the very top, you always have the system level. These are the non-negotiable core operational rules that are hard-coded by the platform itself.
So things like global safety, data compliance.
Exactly. And the fundamental functionality of the LLM. These are the internal guardrails that ensure the agent operates safely, no matter what the user or the developer asks it to do.
So the underlying platform rules always win. If I ask for something that violates a global safety rule, the system rule takes precedence, even if it contradicts the specific instructions I gave my agent.
Correct. The next priority down is the developer instruction. So the rules you set when you define the agent in the system prompt.
And after that,
Following that is the immediate user input, what the user is currently asking the agent to do right now in this session.
and then below the immediate command, we find memory.
Yes. Memory, the long-term preferences stored by the bio tool, sits below the immediate user command. And this is a design choice that really facilitates flexibility.
How so?
Well, if my memory says I always prefer Blue Book citations, but I explicitly tell the agent, for this one report, use MLA, the immediate user command overrides the long-term memory for that single session.
That makes sense. The current immediate command should have priority over the default state. Now, what's at the very bottom of this stack, and more importantly, why is it there?
The very lowest priority instruction is the tool outputs, and this is perhaps the most critical architectural decision for quality control.
So when the agent uses the Python tool to calculate a financial ratio or the web browser tool to pull a news headline, that data is the lowest priority.
Yes. The resulting data is treated as the lowest priority instruction.
Wait a minute, that seems counterintuitive. Doesn't that risk slowing down the process or rejecting perfectly verified data? If the web tool returns a verified Q3 earnings report, why is that treated as the lowest priority? Why trust the internal logic over externally verified data?
This is absolutely key to reliability. The tool output is treated as provisional data, not as the final word. The agent's internal logic, the reasoning engine, must validate, interpret, and process that raw tool output against all the higher-level instructions.
The system, the developer, the user.
All of them.
So if my developer prompt instructed the agent to only analyze reports from companies with market caps over $10 billion, and the web tool accidentally pulls a report from an $8 billion company,
The tool output is rejected,
not because the data is bad.
but because it conflicts with the developer's scope, which is defined higher up the hierarchy. The LLM's core reasoning validates the data's relevance and its compliance with the rules.
Exactly. It prevents the agent from blindly incorporating irrelevant or non-compliant information just because it came from what looks like a verified source. This two-step validation tool execution, then reasoning engine verification, that's the quality control.
That's the whole mechanism.
Okay, speaking of that internal validation, let's move to the central component, the reasoning engine. This is the agent's operational brain where all that logic gets executed.
You should think of the reasoning engine as a really sophisticated project manager. It executes the core thinking process, and it moves the agent from intention to action through 4 primary functions.
Okay, function 1, high-level planning.
It breaks tasks into steps. A complex request, like research 5 competitor pricing structures and write a comparative summary, is systematically broken down into sequential, manageable microtasks.
So it would be something like 1, identify competitor websites, 2, use the web tool to browse their pricing pages,
3, extract and normalize that data using the Python tool, 4, draft the comparison text, and 5, verify the output against all the compliance rules.
That systematization is what ensures efficiency. What's the second function?
It must dynamically choose the correct tool for each of those microsteps. For data normalization, it knows it needs the Python environment. For external validation, the web tool. For long-term content storage, it needs Canmore. The reasoning engine acts as an intelligent dispatcher, knowing which tool is right for the job.
The third function deals with the data that's coming in from those tools.
That's right, validating data. This is where the output from the lowest priority in the instruction hierarchy gets scrutinized. The engine makes sure the information it gathered is accurate, complete, and relevant to the original goal before it gets incorporated into the final answer. It filters out the noise.
And finally, the output function.
It evaluates the results and generates the response. After all the data is verified and synthesized, the engine produces the final, structured output in the format you requested, making sure it adheres to that consistency principle we talked about.
That's the full executive loop. But in high-stakes fields, anything involving finance, medicine, legal work, there has to be a non-negotiable set of architectural guardrails. We mentioned system priority, but let's talk specifically about the final internal component, the safety layer.
The safety layer acts as a continuous critical checkpoint for every operational stage. It runs in parallel to the reasoning engine, and it is non-negotiable. Its main goal is ensuring fundamental compliance and security at the baseline LLM level.
Okay, so how does the safety layer differ from the specialized compliance tools we're going to discuss later?
The safety layer is universal, baseline security. It enforces global rules.
Like,
No unsafe outputs, so no hate speech, no dangerous instructions, and no harmful actions like trying to execute malicious code externally.
got it.
It's also responsible for ensuring no unauthorized tool use. If an agent hasn't been granted access to the automations tool, for instance, the safety layer intercepts that request. And of course, non-negotiable compliance with user privacy, making sure data handling follows all the established confidentiality rules globally.
So it's the platform's general defensive shield.
Right. The specialized compliance tools, which we'll get to, deal with domain-specific legal or regulatory complexity, not the baseline platform security.
So the safety layer makes sure the agent doesn't turn malicious or break platform rules, while the specialized tools make sure it doesn't break, say, financial law or medical protocols defined by external bodies.
Exactly. One is the guardrail for the technology, the other is the guardrail for the domain.
Okay, we've covered the brain, the reasoning engine, and the rulebook, the instruction hierarchy. Now let's look at the body parts.
The tools.
The 9 specialized tools that allow this brain to actually interact with the real world, turning a concept into a functional workflow. This is where the power really lies.
And we really need to dedicate some time here because the utility of this whole framework hinges on these 9 integrated tools. We're not talking about generic plugins. These are tailored, targeted utilities.
Okay, let's start with the utility tools, beginning with the web tool.
The web tool is much more sophisticated than just a simple search query. It's designed for accessing real-time, validated information. Its significance is really rooted in its ability to enforce latest version accuracy.
Right, because when you're building professional agents, you can't rely on stale training data.
You can't.
Give us a professional example of that validation.
Okay, if you're building a legal agent and you ask it about a recently proposed change to securities law, the agent must use the web tool to access the legislative body's website to confirm the current status of that bill.
Not just what was in its training data 6 months ago.
Exactly. Similarly, for market analysis, it's accessing live APIs or specialized financial news feeds. The web tool provides the real-time context that's necessary for automated decision-making in time-sensitive fields like finance, journalism, compliance. It grounds the agent in the immediate present.
Next up is a tool that handles complex data transformation, the Python tool. Now, when a lot of listeners hear Python, they immediately think coding, but here, it's a powerful utility you can access with just natural language.
This is perhaps the most transformative utility tool. The agent uses the Python tool as a highly reliable, sandboxed execution environment, and it serves 3 critical functions that pure text models are just terrible at.
Yep.
First, executing complex, non-ambiguous calculations. LLMs are notorious for hallucinating math results. Python provides 100% computational reliability.
So it handles all the heavy statistical lifting.
Yes. Second, it generates visualizations. The agent can take raw data from a CSV file, use the Python tool to generate a professional-grade line graph or a scatter plot, and then output that chart as a file.
So it moves the agent beyond text into visual communication.
And third, and this is critical, it builds structured files. If your ultimate goal is a production-ready audit report, the agent uses the Python tool to wrap the generated content and data into the required format, a specific docx template, a standardized PDF, a multi-tabbed XLSX spreadsheet.
So that makes the agent a data scientist and a professional formatter at the same time.
It enables sophisticated data analytics and transformation of raw data into these polished deliverable formats.
Now, we touched on it earlier, but the Canmore tool, that long-form writing environment, it needs a deeper look.
The Canmore tool is essential for any content creator working at scale. Its main function is maintaining structural integrity and version control.
Right.
Imagine a team using the agent to draft a series of standardized operating procedures, or SOPs. The agent can manage hundreds of documents within Canmore, ensuring that all 45 of those SOPs adhere to the global structure you defined in the developer prompt.
And what does that version control look like in practice?
Well, in a professional environment, if an agent is tasked with revising a software manual, every significant change it proposes, say, updating all the code examples in Section 3.2, is tracked.
So the user can review that history.
The user can review the version history within Canmore, accept or reject the changes, and even revert to a previous state if they need to. This is crucial for collaborative drafting and compliance auditing, where you have to prove when and why a document was changed.
It turns the agent into a responsible manager of massive text.
A structural manager, yes.
Finally, for utility, we have the key to persistence, the automations tool.
This is the tool that lets the agent break free from that reactive, session-based workflow. The automations tool is used to schedule periodic tasks and set reminders.
So if a user runs a specific market analysis report every Monday morning,
the agent can use this tool to define that as a recurring workflow. It's ideal for scheduled filings, repetitive data ingestion, content publishing calendars, or even defining personal study routines that need daily or weekly execution. It moves the agent from assistant to a proactive manager of your recurring commitments.
that covers the core utilities for data and structure. Let's move to the creative and memory-focused tools, starting with the Imagen tool.
While it seems simple, the integration of the Imagen tool ensures end-to-end content production. If the agent is drafting a presentation using the Python tool to create the slides, it can concurrently use the Imagen tool to generate supporting diagrams, custom icons, or conceptual graphics needed for the final product.
So it's about integrating multimodal capabilities directly into the automated pipeline.
Exactly. Make sure the agent can deliver a fully finished product, not just the text shell.
Okay, for agents dealing with vast, specific knowledge bases, we need the file search tool.
Yeah.
This is critical for leveraging proprietary or highly specialized data.
The file search tool is the agent's research librarian, but it's one with a deep domain understanding. When you upload a folder of legal contracts or medical journals or internal sales reports, the agent doesn't just treat them as generic text. It understands the structure and the intent of those documents.
How does that specific understanding actually manifest?
Its job is to extract highly specific data points that require deep document analysis. For a legal document, for instance, it can extract the ratio dissidende, the core legal reasoning, or specific numbered clauses from a complex contract.
Wow.
For a medical report, it can extract specific patient metrics from tables buried deep within the file. It can synthesize citations and cross-reference arguments across dozens of documents at the same time.
This capability transforms a generic agent into a specialized domain expert that's grounded entirely in your own proprietary knowledge base.
That's it. The agent isn't limited by its general training data anymore. It becomes an expert in the documents you feed it.
And that leads us to memory refinement through the bio tool. We mentioned memory earlier, but the bio tool codifies that memory into stable preferences about you, the user.
Right. The bio tool is what stores the stable facts about the user that define their digital persona.
So how does that ensure the long-term stylistic consistency we talked about?
It could include mandatory brand guidelines like preferred color palettes for generated charts, or mandated terminology that has to be used in all external communications.
Or even a deep history of preferred writing styles.
Yes, like always using active voice or keeping sentences under 20 words. By having a persistent bio tool, the agent applies these preferences automatically without needing them in the system prompt or the user prompt every single time. It guarantees a level of consistency across all generated outputs that was just impossible before.
So it's not just remembering that I like the color blue, it remembers my entire corporate style guide.
It's persistent stylistic governance, constantly applied across sessions.
Finally, we have the gateway and the ultimate gatekeeper, the external connection and the compliance check. We had the APA tool and the Guardian tool.
The APA tool is the external gateway, the connectivity hub. It's essential for any agent that needs to integrate with existing software ecosystems. By connecting to external APIs, the agent can perform actions like updating a CRM database, sending a notification via Slack, or triggering an action in a third-party project management tool.
This is how the agent takes its internal decisions and translates them into actions outside the platform.
That's right.
And let's clearly distinguish the specialized gatekeeper, the Guardian tool, from the platform's general safety layer.
So while the safety layer handles platform security and universal harms, the Guardian tool is the domain-specific compliance checker. It focuses exclusively on high-stakes regulated areas, financial reporting regulations, medical privacy protocols like HIPAA, or stringent political neutrality requirements.
So if I task my agent with drafting a financial disclosure document, the reasoning engine consults the Guardian tool at every step to make sure the language and structure meet the regulatory requirements for that specific industry.
Exactly. Or if the agent is asked a highly sensitive political query, the Guardian tool ensures the response is rigorously nonpartisan, factually verifiable, or ensures the agent declines to answer appropriately based on the system's external-facing policy rules. It's the mechanism that ensures professional responsibility and legal compliance when you're dealing with domain-specific complexity.
This is where we tie it all together. We have the architecture, the rules, and the specialized tools. Now let's look at the operational blueprint. How does the agent sequence all this power to complete a task? Let's walk through the six-step agent workflow.
This workflow is the standardized operational sequence that every single agent follows. It ensures that every complex task proceeds logically, reliably, and with built-in verification.
Okay, step one, input understanding.
This is the moment the agent receives the prompt. And it's not just parsing keywords, it's interpreting the user's true intention and ultimate goal. It analyzes the context of the request, factoring in all the long-term preferences from the bio tool and the limitations from the system prompt before it even starts planning.
Once the intention is clear, we move to the internal strategy session. Step two, planning.
The reasoning engine engages. It immediately maps out the entire task sequence. This means identifying which specialized tools are required, the web tool, the Python tool, etc., defining the sequential steps, and critically, inserting the necessary compliance and safety checks from the safety layer and the Guardian tool throughout the planned sequence.
So this step acts as the agent's internal project manager.
It does.
The plan is set. Now for the action. Step three, execution.
The agent performs the actual external actions that were defined in the plan. This is where the tools are called. Running a statistical model with the Python tool, accessing external data via the web tool, generating graphics with Imagen, or organizing a large document in the Canmore tool. This phase involves a high volume of activity.
Now, we know the tool output is the lowest priority in the hierarchy.
Yeah.
This is where the quality control kicks in, right? Step four, verification.
Absolutely. This is the quality control checkpoint. This is where the agent draws on the reasoning engine to evaluate the results of the execution phase. It checks for three things: accuracy, clarity, and compliance.
And if it fails?
If the web tool returns irrelevant data, or if the Python calculation is correct but doesn't align with the developer's original scope, the agent is designed to self-correct. It loops back to step three and re-executes the action until the verification step passes.
So it minimizes presenting errors or non-compliant outputs to the user.
That's the idea.
Once that internal checklist is satisfied, we get the result in step five, final response.
The agent produces the final, polished output. And because of the consistency principle, this output is delivered in the expected structured format, whether that's a formatted legal brief, a PDF chart, a structured table, or a schedule set by the automations tool. This is the user-facing deliverable.
And finally, to make sure the agent gets smarter over time. Step six, memory update.
If the agent is allowed to learn, it updates its long-term memory via the bio tool with any new preferences, feedback, or style adjustments it observed during the session. This iterative process ensures the agent becomes more personalized, more efficient, and more consistent over time.
When we synthesize this whole framework and workflow, what are the primary advantages for our learner? The person who needs fast, applied knowledge, but isn't a professional software developer.
The advantages for rapid application they're immense. First, the obvious one, no coding required. This democratizes high-level automation. It allows domain experts, lawyers, doctors, accountants to build tools tailored to their professional needs just by describing the process.
Second, the inherent quality of the system's design.
Yes. All the essential tools are built in. The complexity of integrating file search, specialized code execution, version control, it's all handled natively by the platform. You are handed a comprehensive toolbox ready to use.
It's secure.
It is inherently secure and sandboxed, which provides peace of mind about data integrity and operational safety.
And for the person who wants to innovate quickly.
It is incredibly fast to prototype. If you have an idea for a specialized research agent, you can define its identity, give it the tools, and test its workflow in minutes. It allows for rapid iteration and application development without the traditional overhead of software engineering.
This really makes the framework perfect for complex, high-structure environments.
Exactly. The sources confirm its suitability for education, legal, medical, business, and creative work. Any field that relies heavily on structured data, compliance, version control, and complex analysis is an ideal use case.
Okay, let's close this out with the real-world examples that really demonstrate the power of this integrated tool use. This shows the agents operating in tandem.
A fantastic illustration is the PackFiler tax agent. This agent handles a complete multi-stage, high-stakes tax filing workflow.
Wow. Okay, so how would that work?
It would use the web tool for real-time validation of current tax codes, the file search tool to read the user's income documents and expense receipts, the Python tool to execute all the required calculations reliably,
And generate the final compliant filing document.
right, as a PDF or an XLSX file, and crucially, the Guardian tool to ensure every single step adheres to regional tax authority compliance rules. It's a true end-to-end automation of a regulated process.
That's a very sophisticated workflow. What about agents that need to delve into specific proprietary knowledge and extract really nuanced meaning?
That's the legal research agent. It's specialized in extracting ratio decidendi, the fundamental legal reasoning or the established rule of law from a court case.
Which is not an easy task.
No. It's a task that relies heavily on the file search tool to not just find keywords, but to understand and isolate the core argumentative structure of these massive case law documents. It requires a semantic comprehension of structure, not just search relevance.
And for sheer scale and creativity.
The book authoring agent exemplifies the power of the Canmore tool. This agent can manage the entire creative process from conceptual outline generation to chapter drafting, revision, and indexing all while maintaining robust version control of the manuscript.
And it can use the Imagen tool.
It can integrate the Imagen tool to suggest cover concepts or internal diagrams, creating a complete publishing workflow that's managed just by natural language.
Finally, that fascinating example demonstrating multimodal and translation capabilities. The Healthcare Explainer agent.
This agent addresses a critical communication gap. Its function is to ingest complex medical reports using the file search tool, apply its reasoning engine to simplify all that dense medical terminology, and then translate the simplified concepts into accessible language.
The example cited was Urdu.
Yes, into Urdu, while adhering to cultural and stylistic rules stored in the bio tool for maximum clarity and cultural appropriateness. It illustrates how the framework can blend research, synthesis, and bespoke communication skills to solve very specific, high-value, human-centered problems.
So, to synthesize the immense detail we've covered,
The shift from a conversational large language model to a persistent, goal-oriented, autonomous agent is rooted entirely in structured architectural design.
it's unlocked by two major components.
A robust, native set of 9 specialized tools that give the AI functional utility in the real world, and a formal 6-step internal workflow that enforces planning, execution, and critical verification before any output is delivered to the user.
And the overarching concept here for you, the learner, is the accessibility of this power. We have decisively moved past the idea that building powerful functional automation requires coding expertise.
Absolutely.
You can now define complex, mission-critical automation that handles professional functions like structural maintenance with Canmore, deep analytical work with the file search tool, regulatory compliance with the Guardian tool, and persistence through the automations tool, all accessible simply by defining the identity and rules in natural language.
We observed agents handling these highly regulated and complex professional tasks, from complete tax filings to extracting the precise ratio decidendi from legal case law. These are tasks that traditionally require specialized human expertise, lengthy training, and extensive manual verification.
So here's our final provocative thought for you to take away as you consider this new world of autonomous tool-powered systems. If an AI agent, built without coding, can reliably manage, execute, and verify these professional high-stakes workflows internally, what then becomes the most essential, uniquely human element left for us to delegate to the machine?
Or,
more critically, what is the uniquely human task, the ultimate source of creative judgment, context, or critical empathy that we must retain absolute control over?
something to ponder as you start defining the identity of your own specialized agents.
We'll see you next time for the next deep dive.